Hi, good morning to all. Today we are going to discuss about distance time graph. Okay, in the previous class we learned about the uniform motion and non-uniform motion and their difference, how they are different in each other according to the content wise and all that we learned in the previous class, right? And this distance time graph mainly we are using to show how the distance traveled by a moving object changes with the time. When we are using this distance time graph, how the distance traveled by a moving object changes with the time. Okay, papers and all, right? In the graph papers we have number of squares and all, right? And the length of each squares, normally in squares it has 4 sides and each sides will be equal, and the length of one side or each side we can consider in graph paper how many with the help of scale we can measure it. Normally it will be near about 1 centimeter and all, right? Okay, so in this topic we are mainly discussing how can we draw the distance time graph for uniform motion and non-uniform motion, and in the case of an object is at the state of rest, how can we draw the distance time graph. That only we are discussing in this chapter. And by drawing this distance time graph we have some steps, we have to follow some steps. Okay, so that first step means that here we can write first one, draw 2 lines at right angles each other. First we need to draw 2 lines and these 2 lines should be right angle. For example, right angle means what? The angle will be 90 degrees. So one line we draw 2 lines. Okay. And 2 line we draw and this both the lines are right angle too. This angle is 90 degree. Is it right? Yes. And this part we can consider as OX, and O here we can write X and here we can write Y. Each and every case we just give the name for this line. There are 2 lines, one line is OX and the other line is OY. Okay. This line, the horizontal line OX we can termed as X axis. Horizontal line OX we can termed as X axis, and the vertical line OY we can considered as Y axis. This is X axis and this is Y axis. So this is our first step, to draw 2 lines which attain right angle to each other. The 2 lines should be right angle. So one will be OX and the other one will be OY. Okay, and second steps, what we need to do? We have to fix the physical quantity, write the physical quantity in both the axes. What do you mean by physical quantity? The quantity that can be measured is considered as a physical quantity. Okay, and here this distance and time are the physical quantity because we can measure time and distance, right? So we can say that this distance and time are physical quantities. Okay, so we have to fix the physical quantity in any of the axes, either X axis or Y axis. For writing that physical quantities in this X axis or Y axis, it having one more thing we have to think. We have to compare this both the quantities, time and distance, to analyze which one is independent variable and which one is dependent variable. Okay, the independent variable are normally the values that we can change in our own will, that is considered as independent variable. In dependent variables the values will change as a result of this change in independent variable. Okay, here we have to fix the quantities each axis. We have to fix the quantities in each axis. So here normally in x axis we can write independent variable and y axis we can write the dependent variable. And actually this time is an independent variable. Time is an independent variable according to the time. Normally at 8:30 if we are starts to move a vehicle. Okay, so in that time onwards, the time will be, we can't able to change the time, we can't able to reduce or increase the time, but we can, this distance will be variable that we can change, but time it is not in our control, right? So this time we can take that independent variable we can write in x axis. Okay, independent variable is time and a dependent variable is distance. Okay, independent variable, time is an example of independent variable, distance is an example of dependent variable. Actually this distance is depending the time. So that way we can say. And when we fix the quantities in the both axis, that is x axis and y axis, we fix the physical quantity, that is x axis time and y axis distance. And how we are writing them, means whenever we are writing this time or distance, we should write its unit. Okay, normally we know that the unit of time is second or minute or hour. Anyway, we can write it. So here we can consider according to our values. So in your textbook you can see that page number 135, here one table is there, table 13.1. We are drawing the distance time graph on the basis of this table. Okay, here this time is given in minute and distance is given in kilometer. So the same unit we can write here. So how can we write it in a graph? You just think that it will be it's like a graph paper. Okay, so time, after that in bracket we have to write minute. We are writing the values in minute and just an arrow like this. Here also in bracket we can write kilometer and we have to just show an arrow, means this infinity. Okay, so like that we can write. So the second point what we done, fix the quantities in each axis. Each axis we are fixing the physical quantity. Okay, and the third point we have to choose a scale. Okay, third point is choose a scale, which means that in a graph paper we have to, means we normally by using the graph paper we can draw the graph, all these things, and in this graph paper choose a scale. We consider that the distance we have to measure like this in minute, each and every minute. Normally in this case we can take 1 minute by using the scale. 1 minute distance that we can consider as it is equal to 1 centimeter. In the beginning I told you that in graph papers that squares, each and every squares there will be 10 divisions and all. So that we can consider as one complete squares, one side we can consider a length of 1 centimeter, and 1 kilometer also we can write according to this graph paper, it will also equal to 1 centimeter. We are writing these values according to the graph papers. So by using a scale we can just measure, or just we can note down the points like this. Okay, then what? In the fourth point, next step after that, what we need to do? We have to consider all these points, or we have to record the values according to this table, these values. Here you can see first one, time in minutes, 0 minute, distance also it will be 0. Then time in 1 minute, distance is 1 kilometers, like that. So here we can also consider the same way. We have to choose a scale, and the fourth point, we have to mark the values of time and distance. Here we can write 1, 2, 3, 4, 5, 6. These are all the values in minute. Here also we can write 1, 2, 3, 4, 5. Okay. Then what we need to do? Here in this table also you can see that when the time is 0, distance also 0. When the time in 1 minute, distance also corresponding distance is 1 kilometer. So the fourth point is write the values in the axis, or mark the values in the axis. That already we done. Okay. We marked the points in the, we already marked the points in this axis. Okay, and our next point is write the corresponding values. Mark the corresponding values. Corresponding values means that while looking your textbook, page number 135, that table, see here 0 minute, and in the case of here you can see that that means x axis and y axis are intersecting at the point O. This point is origin. Okay, then we can consider that we can mark the corresponding. When the time is 1 minute, the distance covered by the object is also 1 kilometer, right? And this intersection we can mark with an dot. And here 2 minutes it covers 2 kilometers. So here also we can write 2 minutes. 2 minutes, 2 kilometer. That intersecting part just put a dot. Then 3 minutes it covers 3 kilometers. Right? And 4 minute it again covers 4 kilometer from the origin. Okay, and 5 minutes it covers 5 kilometer from the origin. Okay, so we just mark the corresponding values. Okay, and we can say that, and the last point is that we have to join the dots. Last one is join the dots. Where is the dots? Yes, these are the dots that we can join. Here also point of intersection. Okay, so we can extend there and we have to join the points. Then we will get a straight line. Okay, so what we can do? This for your understanding only I drawn this dashed line, or we have to express it in a light lines or dotted lines, or like we can represent it. Okay, for your understanding only I drawn the dashed line. Okay, then we will get a straight line. So the graph, distance time graph, here it is given in straight line. Here it is given a straight line. Okay, so this is the way in which we can show the distance time graph. Are you clear? These are the 6 points you have to keep in mind, that whenever we are drawing, mainly we are using this distance time graph for showing the distance or traveled by a moving object in a time. or in a given time, that is considered as distance time graph. When we are drawing the distance time graph, what all the things we have to remember? First one, we have to draw two lines which is at a right angle to each other. We have to draw two lines, OX and OY, and they are in right angle. Right angle means in between, that angle between the two lines should be 90 degree. Okay, and after that what we have to do? We have to fix the quantities in each axis. Both the axes we have to fix the quantity. What quantity? Physical quantity. Here we have two physical quantity, distance and time. So we need to fix the physical quantity. Why we are writing time in x-axis? Because this time is an independent variable. That means this we can change in our own will. But distance, how far this vehicle or an object travels, according to that time, this distance will changes. So this distance is a dependent variable. That's why we are writing this dependent variable in y-axis and independent variable in x-axis. Every time we have to do in the same way. Dependent variables in y-axis, independent in x-axis. Then we have to choose a scale. That means what scale we choose here? 1 minute is equal to 1 centimeter and 1 kilometer is equal to 1 centimeter. Both the cases we taken 1 centimeter scale we used in expressing this. Instead of 1 centimeter you can use 2. Both the cases. Here if we are using 2 centimeter scale, here also it should be a 2 centimeter scale. Okay. Then here we are using which scale? 1 centimeter scale. After that, write the values in the axis. That means we just put 1, 2, 3 in x-axis and y-axis. And fifth point, write the values. And fifth point, mark the corresponding value. We just must, when with the help of that table, when the time is 1 minute, the corresponding distance is 1 kilometer, and 2 minutes corresponding time is in 2 minutes corresponding distance is 2 kilometers. Like that we are just doing it. After that, after we are marking the corresponding values, we will get some dots. Here you can see there are 5 dots, and last point we have to join the dots. Then what we will get? We will get a straight line graph or straight line distance time graph. Okay, now we can discuss all these cases with the help of various situations. How the distance time graph in different motion. Okay, in the previous class we learned about the uniform motion and non-uniform motion and all. And now we are going to discuss about how the distance time graph in the case of uniform motion and non-uniform motion. Okay. So, the distance time graph, whenever we are drawing the distance time graph, you keep in mind that distance we have to denote in y-axis and time in x-axis. Why? Time is an independent variable and distance is an dependent variable. So, we can consider the distance time graph in the case of various motion and rest case. What will happen? First we can discussing. First one we can consider in uniform motion. Uniform motion. Okay. In the case of uniform motion, we will get a distance time graph in a straight line. That means when we are discussing about uniform motion, I told you that the motion of a moving object or an object which covers equal distance in equal interval of time, then we can say that it is uniform motion. Here also you can see that equal time interval, equal distance, in between 1 minute, in between 1 kilometer. Okay, so by using this distance time graph, we can easily find out the speed of an object in a uniform motion by finding this slope. Like this we will get this slope. Then by using the slope we will get, by dividing it, this length and this length we can divide, then we will get the speed of a moving object. Okay, now we can go to non-uniform motion. Non-uniform motion. Okay, in the case of non-uniform motion, if we are drawing the distance time graph, we will get an curved line. Okay, that means unequal distances in equal interval of time. So, we will get a curved line. So, speed of this motion is non-uniform. Okay, and if we consider third case, we can consider an object in rest. Third case, an object it in the state of rest. So, when we are drawing distance time graph, okay, time and distance, what will happen? Here you remember, listen here. In that case, when an object is reaches, in the case of a car, okay, if we are going outside and when we reach to the home, then what will happen is the car or vehicle we will stop, right? The car means we will stop the motion of that car, right? So, anyhow that car travels certain distance, is it right? Rest. Okay, that means if we are going outside for any purpose, like if we went to Calicut and we will come back to our home with car or any kind of vehicle. Okay, so when we reach home, what will happen is we will stop the vehicle, and after that stop the vehicle for long time, then that vehicle comes to rest. So anyhow the vehicle covers certain distance. Okay, after that it is in a state of rest for long time. Okay, so that time we can say that the graph, that line will be parallel to the x-axis. The line will be parallel to the x-axis. So the speed of this vehicle will be 0. Speed will be 0 when an object is in a state of rest. Actually that object is moving certain distance. After that we stop the vehicle. Okay, and after that when we stop the vehicle for long time, then what will happen? This vehicle comes in the state of rest. So anyhow the vehicle travels certain distance from the origin or initial point. So and we stop the vehicle for long time, then the time is moving actually. It is an independent variable. It is actually time. For example, when we reach the home 9 o'clock, 9 to, so we can say that this is this is the distance time graph for an object is in a state of rest. So in this case speed will be 0. Speed of the object is equal to 0 because that object is in a state of rest and the line which is parallel to the x-axis. So we can conclude these three cases. The distance time graph, in the case of an uniform motion, it will be a straight line, and we can easily find out the speed of the vehicle by finding the slope of this graph. Okay, and in the case of second one, non-uniform motion, we will get a distance time graph like a curved line. Here the speed of an object is non-uniform. Then last case, the distance time graph means that the line which is parallel to the x-axis. Okay, then the speed of that object will be 0. Why? Because that object is in a state of rest. Okay, so that's all about our distance time graph. At the same time we completed our chapter time and motion. Okay, that's all about our chapter, and next class we will discuss the exercise questions. Okay, so that's all about today's class. Thank you.